All right, general math, we are finishing up chapter 11 today. So here in our first example, we have the sample space Z. Z is just the name of this set, and our set is made up of A, B, C, D, and E. So given this sample space, given these elements of the set, what's the probability that we choose a vowel at random? Well, we have a vowel with A and a vowel with E. So there's two vowels out of 5. Our probability is 2 out of 5. 2 divided by 5 is 0.4. Here in our second example, our sample space is the integers from 1 to 10. A, the subset A is odd numbers, and the subset B is multiples of 3. So that makes A 1, 3, 5, 7, and 9 because they're odd numbers in this set. And B is multiples of 3, so 3, 6, and 9. Now the overlap of A and B, what elements are in A that are also in B, would just be 3 and 9. 3 and 9 right here. So using this given information, let's find the probability of B, or the probability that we pull out a random multiple of 3. We have 3 elements right here. So the number of elements in B, that's 3, divided by the number of total elements, so 3 over 10. And that's it. That's the probability that we pick a multiple of 3. What's the probability of A and B? We're going to find the number of items in A and B. That's 2 divided by the total number of 10. And we can simplify that fraction by 1 over 5. Now, what's the probability of B given A? So basically this means we know we're working with A. We know we're working with set A. What's the probability that we select 3 or 9? 3 and 9, there's 2 elements in A and B. So we're going to do the number of elements in A and B. So both of these, and then the opposite number, or the number in the opposite set of the first one. So sorry, I'll explain this again. We have the probability of B given A. So we're going to find the number of elements in A and B. So of both of these combined, that's 2. And then we're going to find the number of elements in the second set right here. So the number of elements in A is 5. So our probability of B given A is 2 over 5. Moving on, there's a family of 4 kids. What is the probability that all 4 kids are girls? So what's the chance that any kid is born a girl? It's 50% or 0.5 or 1/2. So then we kind of move on. What's the probability the first kid is a girl? 1/2. What about the probability the second kid is a girl? Still 1/2. We still one or the other. What's the probability of the third kid is a girl? Still 1/2. And the probability of the fourth kid is a girl is 1/2. So what's the probability that all 4 kids are girls? We're going to multiply all these probabilities together. So 1/2 times 1/2 times 1/2 times 1/2 is 1/16. Same type of problem right here. We've seen something like this with coin flips, so like heads or tails. But this time it's just boy or girl. So what's the probability that the first kid is a boy or girl? 50% each. And then for the second kid, if it's a boy, still doesn't matter, still 50%, still 50% chance. Third time, still a 50% chance, still a 50% chance for everyone. So here are all of our different options. So if a family has 3 kids, this could be the birth order of all of them. So I have a middle sister and a youngest brother, and my family went boy, girl, boy. So oldest, middle, youngest. What's the probability that in any family of 3, so these are options up here, the only girl is the middle child? So let's look out of these options where there's only one girl, and what are the so there's only one girl and she has to be in the middle. These have 3, 2, 2, 1 girl, but it's the first one. 2 girls, 1 girl and it's the middle. 1 girl, no girls. So the only time that it's an only girl in the middle is right here. So the probability of boy, girl, boy is 1/8. What's the probability that a family has at least two girls? That means 2 or 3 girls are in the family. Well, there's 4 different combinations. So 4/8, here's the 8 possible, simplifies to 1/2. Now, when we have independent events, that's 2 or more events that do not have an effect on the probability of one another, kind of like up here, right? The probability of having a girl the second time does not matter if it's a girl or boy the first time, it's still 1/2. So examples like flipping heads or tails, is a kid a boy or a girl? Try to think of some other things. A dependent event is something that does depend on each other. It's like drawing from a deck of cards and then not replacing that card. So what's the probability that I draw a king of hearts first and then a 7 of spades? Well, out of the 52 cards in my deck, there's only one king of hearts. So the chances that I draw out that king of hearts first is 1 out of 52. And then after I've drawn out that king of hearts, what's the chance that I draw a 7 of spades? Well, now we started with 52 cards, took one out, so now our total number of cards is 51 to choose from, but there's still only one 7 of spades. So we multiply these two together, and we have our very small probability right here.